Now that we know about fractions, we would like to be able to do arithmetic to them. And the first arithmetic that we would like to be able to do is addition. Now, the title of this video is adding and subtracting fractions, but remember, subtraction is just adding the opposite. So if we understand how to add fractions, we also understand how to subtract them. Now we're going to start out by considering how we add like fractions. What are like fractions? Like fractions are fractions that have the same denominator. So the kind of addition problem we're talking about is something like, what is 2/3 plus 5/3? And just like we understood whole number addition as adding vectors, we can understand fraction addition as adding vectors. So we can draw a number line, split each unit into 3 equal parts, and then draw the vectors 2/3, that'll be 1 2/3, and 5/3, that'll be 1 2 3 4 5. And then we'll pick up 5/3 and set it down at the end of 2/3. And we see that those add up to 1 2 3 4 5 6 7/3. So 2/3 plus 5/3 is 7/3. Notice what effect that appears to have had. We appear to have simply added the numerators and kept the denominators the same. Does that make sense? Let's look at another number line for a second. On this number line, I'm going to draw out 2 plus 5 equals 7. Look what happens when I take this picture and just scale it down. Other than making my handwriting look really funny, what else does this show us? This shows us that the fact 2/3 plus 5/3 equals 7/3, and the fact 2 plus 3 equals 7 are really the same fact, just drawn at different scales. So just as it's equally true to say that 2 inches plus 5 inches equals 7 inches, or to say that 2 feet plus 5 feet equals 7 feet, it's also equally true to say that 2 units plus 5 units equals 7 units, as we did in the whole numbers, or to say that 2/3 plus 5/3 equals 7/3. This gives us our rule for adding fractions when they happen to have the same denominator. First we add or subtract the numerators, and then really that's it. The denominator stays the same. So just to show you an example without the picture, to add 5/7 plus 11/7, we'll add the numerators, and the denominator stays the same. 5 plus 11, of course, is 16. This works out to 16 sevenths. Notice, even if the two fractions that we started with were in lowest terms, the result, the sum or the difference, might not be. For example, if we go to subtract 5/8 minus 1/8, right, 8's only factors are 2's. So 8 and 5 don't have any common factors, 8 and 1 don't have any common factors. But when we subtract the numerators, well, 5 minus 1 is 4. Let's see, 4 is 2 times 2, and 8 is 2 times 2 times 2. I'm not going to draw the factor trees for these, but you are welcome to. And we see everything in the numerator cancels out. When everything in the numerator cancels out, I just have 1 left. And I've just got a 2 left in the denominator. So notice the difference here was not in lowest terms, even though each of these fractions were in lowest terms.